Hello, Year 9. Today's lesson is about energy resources. So what is an energy resource? Well, let's read the definition there on the screen. An energy resource is a source of energy that is useful to human beings. There are two basic types, renewable and non-renewable. So let's have a look at what those are, the definitions of those two. A non-renewable energy resource is one that will eventually run out. It is a finite resource. It may only have 50 to 100 years left. Things like coal, oil and natural gas and nuclear energy are non-renewable because they will eventually run out. A renewable energy resource is one that will not run out. It can be replaced as it is used. It is therefore an infinite resource. Things like wind turbines, solar power, hydroelectric, and so on are renewable energy resources. Let's focus for a moment on three types of non-renewable energy resource. These are heavily used or have been heavily used by industrial countries, and the UK is no exception to this. They're called fossil fuels because they are formed from the dead remains of animals and plants that died millions of years ago. So coal is the remains of trees that died millions of years ago. Oil is the remains of sea creatures that died many millions of years ago. And natural gas is a product of oil. So these are fossil fuels. There are many problems with fossil fuels. When you burn them, they release carbon dioxide, and carbon dioxide is what we call a greenhouse gas. It builds up in the atmosphere and it forms a blanket of carbon dioxide, which does not let infrared radiation escape back out into space. So the Earth gradually warms up. It's predicted by the end of this century that the temperature of the Earth may increase by up to 5 degrees, which would have a huge, potentially catastrophic impact on the Earth's climate. So here is a summary of fossil fuels. We use them because they have a large energy output. So in fact, Emmanuel College, or Watergate Park in particular, is the site of an old coal mine, and below where Emmanuel is, there is a lot of coal, as there is around the northeast of England. And coal was used, it was dug out of the ground, it was burned in homes, but also burned in power stations. It's very cheap to extract. You can see a picture there of an oil rig. The North Sea has many oil rigs because there is plenty of oil below the sea. It's quite cheap to extract and it's very useful. We need oil. We turn it into petrol in cars and diesel. And it's very, very useful for powering our modern lifestyle. But the huge problem with all fossil fuels is that it produces carbon dioxide pollution. So I'm just going to circle the CO2 there. Just get my pen. Okay, carbon dioxide. That symbol stands for carbon dioxide. Okay, so that's carbon joined with two oxygens. Carbon dioxide is a greenhouse gas which causes climate change. Okay, so let's move on to the next slide. What is global warming? Well, let's have a look at this. Here is the blanket, this layer here of CO2, and that collects up in the atmosphere. Light from or infrared, so this is infrared radiation, comes from the sun and it hits the Earth, causing the Earth to warm up. The Earth then emits infrared, but that infrared can't escape. It gets reflected by the carbon dioxide, and the Earth continues to warm, and it's projected that there'll be a 5-degree global temperature rise by the end of this century. That doesn't sound like much, but that would be devastating. We're already seeing the effects of that. You can see here the polar bear needs to have ice in order for it to survive in the polar environment, but with less and less ice. The polar bears are struggling. There is more flooding. We're getting more extreme weather, more hurricanes, more rainfall, more flooding. You can see here this chart shows that the average temperature of the Earth is gradually increasing. So we need to use less and less fossil fuels, and we need to use more and more of these renewable energy resources because they do not produce carbon dioxide. So these are what we're trying to replace fossil fuels with. You'll notice that more and more houses have got solar panels on their roofs. As you drive through the countryside, you'll notice more and more wind turbines. In fact, increasingly we're building offshore wind turbine farms. And if you look out off the coast at certain places, you'll see hundreds of wind turbines just offshore. Not so much in this country, but in places like China, they're building lots and lots of these huge hydroelectric dams. The water is in a reservoir at the top there, and as it goes down, it will go down through a pipe and it will cause a generator to spin. Tidal power, there are one or two of these in the UK, so as the tides go backwards and forwards, causing these turbines, underwater turbines, to spin, and they create electricity. So there's a famous one in Strangford Lough in Northern Ireland. That was tidal. Biomass, well, this could be burning wood to create heat, but in Brazil they grow lots of sugar cane, and they turn that into ethanol, which is alcohol. And ethanol is, instead of putting petrol in their cars, they put ethanol in their cars, and that is much more environmentally friendly, because when you grow more sugar cane, that reabsorbs the carbon dioxide, so it becomes carbon neutral. As long as you keep growing more sugar cane, or if it's wood, you keep growing more wood, it's carbon neutral. Finally, we've got geothermal, places such as Iceland, where there are hot rocks below the ground. What they're doing here is they're pumping water down deep into the earth. The water gets heated, superheated by the rocks, the hot rocks underground, and that comes shooting back up as steam. And that steam can be used to drive a turbine and generate electricity. The steam can also be used just to pipe into people's homes in pipes, and that hot steam and hot water will heat their homes. So here are 6 different ways of generating or producing energy, which is much better for the environment, because none of these have a net impact on carbon dioxide production. So they're all either carbon neutral or carbon zero. There are various advantages and disadvantages of each one, and you should become familiar with these. I'm going to go through these very quickly with you. Start with solar. So the advantage of solar, it's non-polluting. There's no carbon dioxide. Very, very good in hot countries, particularly good in places like the Sahara. Lots of potential there to have solar panels in the desert where there's nothing much. So we wouldn't be disturbing animals or people very much. The disadvantages, well, not very good for the UK because it's cloudy and cold and short days in the winter. Next one is wind. Again, it's non-polluting and there's no CO2 produced. Excellent in the UK. We've got lots of offshore wind farms. In fact, I think the UK might be the leader in this globally. Disadvantage, it's not reliable. What does that mean? It means that it's not every day that it's windy. Wind strength is variable. Okay, sometimes it's windy, some days it's not. Next one is tidal. This is where we use the tides. As the tides move in and out, we can generate electricity from turbines that spin. I've already mentioned one in Strangford Lough in Ireland. The potential is huge, particularly in River Severn in estuary, as the River Severn goes, as the tide comes in and out, you could build a barrage across the estuary and have wind turbines, sorry, not wind, underwater turbines. The problem though, the disadvantage, is very, very expensive and also damage to habitats. Okay, next one is geothermal. Again, it's not polluting. Very, very good in countries like Iceland, where they have lots of volcanic activity and hot rocks under the ground. Not very useful in the UK. There's only one place where there's a hot spring, and that's Bath in the south of England, and that is already a historical site, so we couldn't build a geothermal power station there. Next one is hydroelectric. Big advantage is non-polluting. There's no carbon dioxide. Potential to generate huge amounts of electricity. You need to have the potential mountains to build dams across and to dam lakes. Big disadvantage, very, very expensive to build and damaging to habitats. Okay, next one is wave. Again, this is where the wind makes waves on the ocean and you can make little turbines spin in the sea. Big advantage, it's not polluting. However, nobody's really cracked this technology successfully. It's very difficult to turn wave energy into electrical energy, and don't think anybody's done it reliably. Finally, biomass. We've talked about ethanol. Ethanol in Brazil, you can even use wood. This is very good in hot tropical countries like Brazil, less good in cold countries like the UK. And then finally, the disadvantage of biomass, in Brazil, they've had to clear huge areas of rainforest so they can plant lots and lots of sugarcane, and that's not great for the environment either. So you need to make sure that you're familiar with advantages and disadvantages. The main advantage of all of these renewable sources is non-polluting, no carbon dioxide. Okay, let's move on. So you should be able to answer these questions for all of these different renewable energy. You should be able to say what energy changes are taking place and explain how it works. Is it useful in the UK? Where in the world would it be useful? Why? What are the advantages? What are the disadvantages? You should be able to answer those questions for each energy resource. This is, if we were in the school lab, we would be doing a practical. There's two practicals that we would do. The first one is a model wind turbine like this. This is what it looks like. I'm just going to quickly explain it to you. You've got a model wind turbine here. This one has got 6 blades on it. We use a hairdryer over here to push some wind. Yeah. So create some moving air, make the turbine spin, and then you record the voltage on the voltmeter. The faster it spins, the bigger the voltage. So looking at these results, what we did in the first experiment at the top here is we changed the blades, right? So this one's got 6 blades. If you look in the table here, what we did was we start 1 blade, 2 blade, 3 blade, 4, 5, 6. We found actually that the best wind turbine, the one that produced the best voltage, was actually 3-bladed wind turbine is best. And you'll see that around the country they've got 3 blades on them. So it's not just our practical in the lab that shows this, but actually engineering shows around the country that 3-bladed wind turbines are most efficient. They produce the most output energy. Okay, another experiment is you can change this distance here, and you can move you can reduce the airflow. If you move the fan backwards, you get less airflow, and of course then the turbine will spin more slowly. Okay, so let's look at the next one. This involved a solar panel. Okay, so we've got here a solar panel. You've got light coming down from the lamp. Okay, and what we did was we increased the distance, so we had the lamp down quite low to start with, and then we moved it up by 10 centimeters at a time, and we measured the potential difference on the voltmeter there. And not surprisingly, the closer, so when it's only 10 centimeters away, you get more voltage from the solar panel, and when it's far away, you get less. Okay, so increasing the distance reduces the light on the solar panel, and you get less potential difference. This is something you could have a go at. You've got to rearrange the letters in brackets here, and you've got to try and think of what word you would put into the missing space there. Okay, so what I might do is put that on a little test for you to complete on its learning. Thank you for listening. You can play this again to go over the main points, and I will put on its learning a mini test. I will also put a couple of past paper questions in an assignment for you to have a go at. I'll keep that fairly simple, keep those fairly straightforward, so just 2 or 3 questions and you just type some answers in. But make sure please that you do the mini quiz. Thank you very much for listening. Goodbye.